I keep talking about savings. So let's go through these one by one. The multiple circuits, the derating, the OPMW, voltage regulation, right-of-way, and going to the bus. Here is an interesting project called Caribou Wind Farm. This is outside of Bathurst in New Brunswick, and building this maybe 14, 15 years ago. They put 3 circuits, bare wire, vertical construction, stressed the living daylight out of these poles. There's guys everywhere. It's unbelievable. First winter, first major ice storm, this whole thing was on the ground. Now, if you compare that to 3 circuits on a pole, and these poles have got to be 20, 15 feet shorter than the poles we just showed you. So the loading on these poles is significantly different than those bare wire poles. Plus, there's no threat of these coming down in a windstorm, an ice storm. We talk about multiple circuits on a pole. With bare wire, again, we're limited to 2 circuits per pole. I can see 3 circuits per pole. Don't like it. Linemen don't want to work on it. It's cumbersome, if you will. With spacer cable, you can put as many circuits on that pole as you want. You can put 10, 15 circuits on that pole if you want. This translates to lower number of poles, reduced pole costs, less real estate required for collection system right-of-way, and more real estate available for solar generation, for panels, for revenue generating efforts, if you will. We talk about massive ampacity derating of underground cable. A lot of the solar ranches are usually in the desert. I've got high soil resistivity, high soil row, infinite row. We've got a hot desert climate. We've been designing for as high as 125 degrees Fahrenheit ambient, 50-year high out in the desert. When you've got infinite soil row and 125 degree ambient, the cable is unable to dissipate any of that heat, which results in a massive underground, massive current derating. Here you can see this is in the early days when they were still ending the collection circuit outside the substation. They were using an underground riser going into the substation, underground, under the fence. So you can see here we've got a 1033 kV KC mill spacer cable. And that is equivalent to ampacity to 2 paralleled 1,000 MCM underground cables. Just a massive difference in construction and costing. We want to put the fiber optic in the messenger. Save 5 feet on the pole height. We're going to save on a second messenger for OPGW or ADSS. So less pole height means less cost, less tower shading on panels, which otherwise diminishes megawatt production. Here's a project we did with CG Power called Power County in American Falls, Idaho, and the consultants put the fiber in a separate fiber line 5 feet above. Looks fine. Here's what we started doing around 2012, just putting the fiber right in the messenger. It works fabulous. You don't need a second messenger. Your poles are 5 foot shorter. All kinds of engineering, technical, cost benefits, and aesthetics. And then we can go directly to the substation bus. We said usually you're ending at a pole outside the substation fence, going down to a riser and going under the fence to that sub. So underground and bare wire collection systems usually dead on poles outside the sub. Everything. Transition to underground, then enter. Transitions, terminations, burying, digging things up. It's very costly. Trenching. With spacer cable, the collection system goes from the last pole outside the substation fence, directly over the fence, right to the substation bus. There's no transitions or other costly components. And there's massive, obviously massive savings for labor as well as for components. Here is one of the wind farms. We just put those 3 circuits, turned them on an angle on a pole outside the substation fence, ran them right up to the substation bus. No messy underground connections. And here's another project right to the substation bus and to a switch. We talked about less right-of-way for collection circuit. For underground cables, we'll say each circuit's got to be separated by 6 feet. So we took a look at the DSSR or the Topaz projects. There was 550 megawatts, 11 collection circuits. Of 11 circuits, I need 72 feet of right-of-way required for spacer cable. That right-of-way required would be for a single pole line, and that requires about 1/3 of the real estate required for bringing that 550 megawatts in with underground cable. So the extra real estate freed up from collection system right away is now available for more panels and more productive megawatt production. Maybe a little bit difficult to understand the savings related to improved voltage regulation. When I have compact spacing, a spacer cable, it reduces the impedance by 15%. Okay, so I'm going to build a line 15% longer, or I'm going to have a 15% better voltage at the end of my line. So this is going to quite possibly result in the selection of a smaller cable size, which is a massive savings in aluminum purchase. And again, this is savings when we're comparing to bare wire, not to underground cable. When you're buying underground cable, you're buying a lot of aluminum. Here is a matrix that says underground versus bare wire versus spacer cable, cost, right-of-way requirement, voltage drop, maintenance, avian protection, reliability, and the fiber. If we take what are the determining factors for the value proposition favoring spacer cable, favoring bare wire, favoring underground cable. First off is the facility layout. Are all the collectors coming down a single right-of-way line to the sub? Are all the power blocks separated? So do I have all of my panels in one location and then a mile in a straight line is the substation sitting underneath the transmission line where I got to pump this power back onto the grid? Well, if I got one straight line for 1 mile for all of my collectors, you're probably going to favor spacer cable. Depends on the size. So it depends on other factors. Number two, the collector length. So the short, medium, or long. Again, if they're short, who cares? It really is not going to be a value proposition for spacer cable. If they're long, you're going to save a lot of aluminum because of the reduced voltage drop. What's the collector size? Years ago, we're building 10, 20 megawatt collectors, and 30, now 40, now 50 megawatt. Collector circuits are getting bigger. Line losses are important. Voltage drop is important. So as they get bigger, you're more able, it's more favoring spacer cable. And this will come out in the wash. Number four, facility size. At some megawatt size, sites are big enough with numerous collectors that spacer cable is significantly lower in cost than other options. Again, above 150 megawatts, spacer cable is probably a slam dunk. Unless the power blocks are surrounding the substation and, you have proximity. Lastly is the site density. Sites are very, very dense with panels, meaning minimal extra real estate for collectors. Trenching and underground takes lots of space, which is better freed up and used for more panels. So there's all kinds of factors, and, we can help the consultants through a feasibility study for these projects that they're looking at evaluating the options, one versus the other. Yeah, so if we can make a quick summary, we've got 73 years, 7 continents, 75 countries, collection system of choice for medium to large solar and wind facilities, spacer cable, improve reliability, reduce costs, and it's an option for cost benefit, economics, environmental stewardship, and APLIC compliance.